We proceed with our review of the ST2110 signal analysis capabilities of the Atlas NG. This time, we'll show you step by step how to conduct PTP measurements, ensuring accurate timing synchronization in your media workflows. While in this mode, if we drag the left menu to the center of the screen, we can set up several parameters that define how the PTP clock information in the network is configured. All of them need to be edited properly to ensure that the PTP clock information is received correctly. PTP source. We select here whether we want to receive the primary or secondary PTP clock. PTP VLAN status and ID. In case a VLAN is used, we use these fields to activate and define the VLAN ID for the VLAN carrying the PTP clock packets. PTP domain. This is another identifier that corresponds to each master clock in the network, whether it is primary or secondary. It must match the PTP master clock domain ID in the network. PTP mode. The master clock always uses multicast streaming, but the rest of slave devices can stream under multicast, unicast or hybrid modes. PTP QoS. This is a value that determines the priority level of the PTP clock messages within the network. PTP delayed requests. This field defines how often the meter sends a request to the master clock so as to calculate the latency. It should be a low value, for instance 125 milliseconds or 250 milliseconds. PTP timeout. It defines the number of unanswered requests that the meter must send before switching to the secondary clock. Some of the most significant parameters being reported in this widget's screen are the number of delay requests, delay responses, presence, and PTP status, for there are different PTP signal locking levels. To sum it up, the PTP status should show that we are fine locked. The sinks, delay requests, and delay responses counters should be incrementing, with the delay responses value being close to that of delay requests. Presence should show present, and the domain should match that of the master clock.